We're going to look at how we pass pointers from one application to another, specifically passing them from functions to functions, because pointer stores memory addresses. We'll be looking at how passing memory addresses is done from one side to the other in this video. This example illustrates the fact of passing parameters here by value, right? So this is exchange function declarations here, and definition is here. So because we're not passing these integers by pointers, they are being passed in by value, passed by value. So this means that the moment that both x and y receives value, they are being copied inside this functions on the memory. So there's actually a copy of x and y sitting in memory that are doing the following, right? So what is this following? This is the swapping mechanisms, right? So basically what we're doing is x is coming in as 5, right? This is 5, this is 7. And y is coming in as a 7. Set up a temporary variables as part of the swapping mechanism to swap the value of x and y. So x is now going into temp, right? This is a temp value right here. So we're setting x, which is 5, right, into this value, right? While we said x now equals y, right? So this means that y is here. Y has a value of 7. So this value is going to go in there. Therefore, x's value is no longer 5 but 7. And now we set the value of y back to temp, right? Temp was 5 before, right? So now this goes back there, right? At the end of it, what we have is y no longer has 7 but 5, right? So this illustrates how we swap, right? These two values in place, basically inside this exchange function. Do you think would A be 7, B be 5 after this exchange? The answer is no, right? There's actually no change, okay? And the reason is because the effect of swapping happens inside the function, and whatever is inside the function is of a function, what we call function scope, right? Function scope is local to that function, which means even though x and y are being swapped in value, because they're passed in by value, the effect stays inside that function and does not persist outside of the function. So this illustrates the exchange happening inside a function but not outside. This is the reason why the exchange is called unworkable. Now, this is the same exchange mechanism making use of a temporary variable here. However, we're passing the arguments by pointer, right? So what gets passed in is a pointer. So A is still 5, B is 7, right? And we're passing in the memory address of A and B. And so basically there are pointers in exchange. So the argument list, the parameters list here shows 2 pointers, Px, which is a pointer to X, Py, which is pointer to Y, right? And by swapping, right, it's the same mechanism. We have a temp here, right? Temp here stores, right, dereference X. So if you dereference X, X used to be A, right? A is 5. So this actually gives us a value of 5 right here, this very first one. So note that we have Px here and also Py, right? If you dereference Px and Py, you get these. So Px has still got 5, right? So Py, dereference Py is actually 7 here, right? So if we set Px equals Py by dereference, we're setting this to be 7, right? But Py, right, when you dereference it, still has 7 here, which is the value of B actually. And now we said dereference Py equals temp, right? So this temp actually goes here because temp has 5, right? This 7 is out as 5. Now, remember, we're talking about dereference Py. So there's this P and Y, right? This actually points to their original memory location, which is A and B right here, right? The address of A and B. So what we're doing here, passed by pointer, actually changes the original values of their variables. You know, by passing pointers into another function, we're able to change the values that these pointers point to right here, right? So A used to be 5, B 7, and now is A is 7, B is 5. The reason is because we're passing the pointer to A. So just notice that even though PX, right, points to A and PY, right? Remember, PX, PY, they are pointers. So they store the memory address of A and B respectively. These memory addresses don't change as long as you don't stop your computer. Your program is actually at runtime. So these memory locations are fixed, right? And this allows you to change the value within them using the pointer. So this is what we meant by pass by pointer. Okay, so this is a very important concept, which is very, very different from pass by value. Every time we want a call function to have access to a variable set on calling function. So calling function could be function A. Okay. And the call function could be function B, right? This is the called function, and this is the calling, right, function here. We pass the address of that variable. Let's say if we're going to pass a variable X. This is an integer X right here, right, inside this function. We pass the address of that X. We pass the address of that X, right, to the call function and use the indirection operator to access it, right? So in this function, what we can do is we use the indirection operator, which is that star, right, in reference, to access, right, the value of X, right? Inside this function, you can actually write using a different parameter, right? This parameter is not, it's really the address of X right here. So this Y, when you dereference it, gets the value, right, of original variable, which is X. That's what this is saying. The way to think about this is you're passing this remote control now into this function, remote function. And this remote function, by way of using that remote control, can control the value of the original variable, right? This is significant in C and C++, in that you can just pass, instead of the entire value of X or the object itself, this doesn't have to be an integer, it could be any object or instances in memory. Instead of passing them completely by value, now you're passing the memory address, right, of these objects, right, by way of using a pointer. So this entire pass by pointer programming paradigm is such a fundamental feature of C++. It makes programming in C++ unique. Later on, we're going to introduce what's called pass by reference. That is a little different. References and pointers are two different things and have different properties associated with them. But right now, let's just keep on, focusing on how we pass pointers, right, from one function to the other or from one application to the other using this entire mechanism as described. This example illustrates passing by pointer here, the address of A and B, which we get from, user entry. This smaller function, which is declared right here and defined right here. This is this actually is what we call a ternary condition. This is dereference px, dereference py, right? So these are passing by pointers. So both px and py points to the original variable a and b. So these a and b are global variables in relations to the location of px and py here in code. So this is saying that if a, right, because when you dereference px, you actually get a value of a. If a is less than b, right, then we want to return this. So what is px? Px is a pointer pointing to original A right here, right? Now, if y is less than x, then we return this, right? So if this evaluation is true, then we take this. If false, we take this, okay? So this is true, this is false. Nonetheless, we're returning a pointer back, right, to the caller. Both A and B exist, right, in memory. So whatever inside this function stays inside this functions, right? Nothing, with the exception of returning this pointer. Let's say if you have a local variable in it, and you try to return the address of that, right, as your function return type here, that's going to cause an error. So in other words, if we illustrated this instead of saying returning this, and we said we want to return, right, a local variable, let's say the address of k, and in this case, let's say there's an integer k here equals 5. You try to return address of k and forget about this. Now, this is going to be a problem because as soon as you exit this function, right, this function scope is entirely reclaimed, right, back to memory. So whatever local variables you have, in this case, you have k, would have been reclaimed. So the address of k would no longer be valid. So even if you return it here, this is supposed to be the address of k. This k would have been obliterated and maybe used by other parts of the memory or running programs. So this k no longer exists. So you can't just return that. In fact, on most of IDEs, you get some sort of warning. But in older IDE, you may get program crashes saying that you can't do this. And just to reiterate, right, it is an error, right? Serious error. Sometimes on IDE, it's what we call warning. Serious error actually leads to crashes or incorrect programming results or computations. When you return a pointer, right, to a local variable, this local variable could be a part of your function. So when that function exits, the address that you use to point to that local variable becomes invalid. What you can do is you can return a pointer to a global, right, variable. For example, a memory address of a global variable that persists throughout the entire runtime. The address of this something, right, is known. When you're using pointer, you got to make sure the object that this pointer points to persists throughout the program. Otherwise, this pointer will have become invalid, right? And that will cause crashes, that will cause the wrong computations, wrong results, and things like that. And that's what we meant by serious error, because your problem, your solutions does not solve, what we need.